really wanted to find a typical exam question like this one to do with you. We love to give questions that involve a parabola and a straight line on the same set of axes, and this particular one has two sets of straight lines. Now the types of questions are more interesting, like this one over here. Point D if OD is equals to a third of OA. It's a really tricky way of asking a simple concept. Let's see if we can find another one. The coordinates of G, the point of intersection of the parabola and CG. It's just, we say it in such a strange way that people get confused, especially if they haven't done enough practice. Remember what I always say, the more you practice, the better you get. So practice lots. Now let's read the question. The equation of the straight line through the points A and B is y is equals to negative 3x and 9. So we're talking about this point and this point over here. And there's the straight line. This is the formula. We need to determine the coordinates of A and B. Well, the first one is easy because it's a y-intercept. And in terms of our straight line graph, the y-intercept is always what's being added. So A, being the y-intercept, is going to have a value of 0 and 9. Now B is slightly more tricky because it's the x-intercept, but that just means we need to make y equal to 0. So 0 is equals to negative 3x plus 9, and let's solve for x. Take the 3 over. Remember, we're just subtracting 9 from both sides, but we talk about taking it over. Because it's adding on the other side, it subtracts on this side. And now we're going to divide both sides by negative 3, and that will give us an answer of 3 is equals to x. So therefore, B has a value of 3 and 0. I like the next question. The coordinates of C. I spent a while looking at this going, but we don't have the equation of the parabola, and we don't know what this line is. How are we going to work out C? And then I remembered that in grade 10, the distance from the origin to the x-intercept is the same length on both sides, which means if B is 3 and 0, C is automatically going to be negative 3 and 0. Sneaky way of asking it, isn't it? Now this question's quite interesting. Point D if OD is equals to a third of OA. Now OA is the distance from O to A. What's that distance going to be? Well, what is the y-intercept over here? Let's just write it down. 0 and 9. So what's the distance of A from 0? Well, OA will equal a distance of 9 units. So if OD is a third of OA, it must mean that OD is equals to 3, which means that D has a measurement of 0 and 3. Not a measurement, but a coordinate of 0 and 3. Now the reason why I haven't done all of these calculations down here is because this is really a 1-mark question. We just want to know, can you figure out the distance between the origin and the letter is the y-intercept, and then can you divide by 3? Which of course you can do. You are in grade 10 now. The next question asks us to find the equation of the parabola in the form y is equals to ax squared plus q. There are two different ways you could do this. You could either substitute the points that you know, so A, B, and C, and then use simultaneous equations to solve for all of the things. But I want to show you this other way right now, and that is we use this formula. Now this formula won't appear on your formula sheets, so if you like it, which I know you are going to, you need to remember it, just like I have. Now you must be wondering why I have x1 and x2 and then normal x and normal x. Well, x1 is our first x-intercept, so let's say it has a value of c, which is -3, and x2 would then be b. So let's switch back to green. We don't know what a is at the moment, so we'll have to leave that blank, but we can substitute -3 taken from point C because it's the x-intercept, and there's the value of point C, and then x minus 3, which is taken from point B, which gives us a formula of a is, y is equals to a, x plus 3, and x minus 3. And I can see I'm going to run out of space here, but let's multiply it out. We'll start by multiplying the brackets, and I'm going to be sneaky because I can see that these two brackets are the result of a difference of two squares. So I know that it's going to be x squared minus 9. Now I need to solve for a. The only way I'm going to be able to solve for a is if I substitute another point on the parabola into the equation. So let's move across, and let's substitute the point we haven't used, which is point A. So it's going to be 0 and 9. 9 is our y value. A we don't know. Then we've got 0 squared minus 9, which means we've got 9 is equals to minus 9 times by a. We're going to get rid of the minus 9 by dividing both sides by minus 9. 9 divided by minus 9 gives us minus 1 is equals to a. That means we have y is equals to minus 1 x squared minus 9. The last step, you see I substituted it into there. The last step is to multiply out those brackets, and then we have y is equals to minus x squared plus 9, which makes perfect sense because our y-intercept is 9. So it's all good. It really is. Fantastic. The next question says the equation of the line CG. So let's look at the line CG. It's this one going up here. There's point C, and we know what point C is. It's -3 and 0, but we don't know what point G is. We also don't know what point F is. Do we know what point D is? Thankfully we do. It's 0 and 3. So if they want to know the equation of line CG, and we have y is equals to, you can say ax plus q or mx plus c, where c is the y-intercept, so c is equals to 3. That means we've got y is equals to mx plus 3. We're going to substitute, let's just write subs. We're going to substitute the other point, -3 and 0. Why are we doing that? To figure out what m is equals to. Let's squeeze it up in here. Times by -3 plus 3. We'll take the 3 over. So now we have -3 is equals to -3m, which means m is equals to 1. So the equation of this line is y is equals to 1 times by x plus 3. Okay, there we go. The coordinates of G, the point of intersection of the parabola, and CG. what does point of intersection really mean? Well, in English terms, that point of intersection would be where the two graphs, the parabola and the straight line, come together. So at that point, they're both equal to each other, which means that x will have the same value on the parabola as the straight line, and y will have the same value on the parabola and the straight line. And this is the trick to it. We take the parabola formula of y is equals to negative x squared plus 9, and we make it equal to the straight line formula of y is equals to x plus 3. So let's do that. Negative x squared plus 9 is equals to x plus 3. You see, it's simultaneous equations. Nice and easy. Now I know this is going to be a quadratic equation, so I'm going to take everything over to one side, and then I'll have x squared plus x minus 6. And because I am so super intelligent and also running out of space, I'm just going to factorize it in one step. It's going to be x plus 3 and x minus 2. And you're welcome to check my calculations. Pause the video for a while or something. Which means that x either has a value of negative 3 or it has a value of 2. So let's go back to the graph. We know that the two functions cross at point C where x has a value of negative 3. So although this is a valid answer, we don't need to work with it any further. We just need to work with x is equals to 2. So I'm going to substitute that, subs x is equals to 2, into whichever equation I like the most. And honestly, I would want to avoid the negative and the squared. I'm just going to substitute it into the straight line. So plus 3, and let's substitute it in now. 2 plus 3, which means y is equals to 5. So point G is therefore x is equals to 2 and y is equals to 5. Not so bad. The last bit asks for the range of the parabola. Let's just switch colors again. We're now on to purple. The range of the parabola are all of the possible y values that the parabola can be. Now, here's the maximum point of the parabola. Parabola does not exist above point A, but will continue to go all the way down forever and ever and ever and ever after or before the value of y is equals to 9. So that means that the parabola has a range of y is less than or equal to 9. Nice and easy. Okay, well that was a typical grade 10 exam question. You were asked to find x-intercepts and y-intercepts. There's your y-intercept, x-intercept, another x-intercept, another x-intercept. So funny ways of asking them. Then you were asked to find the equation of the parabola and the equation of the straight line. To find the points of intersection, which of course means we're doing simultaneous equations, and then the range of the parabola. Not so bad. I would practice about 5 of these types of questions and do each question 3 times, each time focusing on being more correct and faster. Good luck.